Okay, question 4.7 was my dovetail calculation. So they said the included angle of an internal dovetail, so remember this is the part that can move in or out in your tool post, must be calculated and tested for accuracy using 3 rollers. So there's 2 big ones and a small one, as seen in figure 4.7 below. Calculate the included angle of this dovetail. So if you look a bit closer to this now, you have at question 4.7 the small roller and then the large roller, which means there are 2 radius points or middle points are different heights now. So if you draw a line straight, that will be your length of the triangle that we're going to look at. You'll see it in the sketch L as well. Then from there up until there, it's going to be the 2 radiuses minus each other. So 9 minus 3, which gives you 6. And then you have your skein say there. So we're going to have to use, to get this small alpha angle, and times it by 2 to get theta. It's exactly the one that I showed you in class as well. Okay, so first of all, we're going to have to get this length over there. So that's where we're going to have to use the 2 distances. So you have the big distance, which is the distance from the large roller to the other large one. And then the small one is from the large roller to the small roller. Okay, so to get this side over there, the L, you have to say the large distance minus the large radius minus the small distance minus the small radius. Okay, that's going to give you that side over there, because now you're taking away this gap and that gap minus the radius. Okay, so the big distance is 107.39 minus my large radius is 9, and then the small distance is 91 minus the small radius of 3. So if you just put that into your calculator, gives me 10.39 millimeters. You have to write millimeters, please, otherwise you don't get the marks. So 1, 2 marks over there. So then, because I have this distance over there now, I can go and calculate this angle, because it's opposite over adjacent. So tan is what you use when you have the opposite and the adjacent side, remember? And my angle that I'm using is alpha. So the opposite side is the 9 minus 3, which is 6. And my adjacent side is the one that I just calculated, the 10.39. So now you go say shift tan 6 over 10.39. And that gives me 30 degrees. Okay, 0.00, so it's fine, or 0.1. If you just wrote 30 or 30.01, it's also fine. So that's 2 marks over there again. So now to get theta, you have to say alpha times 2. So 30 times 2, which gives me 60 degrees. And there's your last 2 marks.